Hey guys, how you doing? Gary Peterson here. Today we're going to be going over the Eagle Impact Uni-vent. So we have a couple different ventilators that we use for transport in our service, but this is the most basic. It's also the oldest, and you'll see that pretty shortly. So we're going to go over the basic features as well as the basic operation of this vent. So just to get started, here's where all of your inputs and outputs are as well. You have your 50 psi line, and that's just stored in its own little pouch. When you take this out, you notice that it has a connector. It has the threaded connector which would go onto the O2 bottle, either in your portable bag or mounted onto the stretcher. It has the quick disconnect feature here that pops that off, and therefore you can be on the bottle, you can disconnect from the bottle and immediately go into the side port of a wall, either at the bedside or more appropriately inside the ambulance. So you're going to run off of portable oxygen while you're moving the patient to and from the ambulance, and then you're going to be running off of the main oxygen because these guys tend to eat down a lot of oxygen during the actual transport itself. So that's your 50 psi line connected right here. We tend to not bleed too much other gases in. It'll say air in right here. Here's your exhaust line where your vent circuit tubing is going to come out. You have your power line here, and that is connected to this crazy big module. You got a big AC converter, you've got the black power line, and then you have the actual gray line that feeds from the converter to it, and then this is to help extraneous cyclical power. So you've got a red dot on there, so I'll bring that closer so you can see that. So there is a red dot on this cable, and there is a red dot at the very top of this circle. So if you line the two up, then the, 6 pins will line up, and it goes in. Now pulling it out, it's just a straight pull, but it's also very stiff. So you gotta really give it a little bit of something, and it's gonna come out for you. You're not breaking it, it's just a straight pull out. The last two are going to be your exhalation valve and your transducer. Now the nice thing is that one is just straight metal colored, and the other one has a color to it, kind of like a greenish color to it. So just to review, we've got our power line, our bleed in for various air products, if you were going to bleed helium into your line or whatnot. This is your exhaust line for actual out to the patient. This would connect to your regular vent circuitry. Your 50 psi for oxygen, and then you have your exhalation valve and your transducer. You notice this one's silver colored. This one actually has a color to it, and that's going to come in handy for us in just a second. So we have our vent package. It's going to come in like this. It's got everything you need here, plus even one extra small corrugated tubing. The extra small corrugated tubing, about 2 feet long, is actually to hook up humidifier. During transport, since our transport times are usually under 2 hours, we don't usually worry about humidifiers. So we dispose of that piece. When we open that up, we have this circuit right here. The first thing that you're going to need to do is these extra monitoring lines are not attached to the main vent circuit. They need to be attached. And when we bring them close, you've got a couple different attachment points that you see. You've got this guy right here, and you've got this guy right here. Well, clearly you see the actual membrane here. That's your valve. That's your exhalation valve. So these two lines, thankfully, are two completely different diameters. This blue one is really fat, and the white one is much more narrow. The white one will not go on this one. It won't fit. It will only fit on the narrow one. Likewise, the blue one will go on the big one where it's supposed to go. If you try to put it on the narrow one, it won't stick. So the only way you could goof this up is to be really creative and use tape. So if you're using tape, you know you're doing it wrong. We put this where it belongs, and put this guy where it belongs, and now we know the white line is connected to the exhalation valve. The blue line, since this is connected to the patient, the blue line is proximal to the patient. It's your prox line. So we've got nice little holder positions here, so we can snap that into our line. We can run this all the way back. So very simply, we have the large vent line, fits snugly there. The clear line goes to our uncolored one, and our colored line goes to our colored line. So our transducer, our prox line, is now proximal to the patient, and our exhalation valve is actually at the exhalation valve, tracing all the way back. If for some reason you were trying to reverse these, number one, just like on the front, they can only fit one way. On this side, they're two completely different diameters. They only fit one way. So if you're finding that you're needing to do something creative to get them to fit, you're doing it wrong on this ventilator. So now we've got our vent circuit hooked up. I'll go ahead and take my test lung and hook it up to my vent circuit. We are ready to go over some operation. This has a protective case. And one of the downsides to this particular ventilator is that, well, it's very old, so it's pretty heavy. It's pretty compact and very durable. You can throw it down a flight of steps, it probably would still keep working. This one here is old, so our battery life is down somewhat. It's supposed to have like a nice long 6-hour runtime. Unfortunately, this one can die after only about 45 minutes. Your transfer time at bedside can actually be kind of extended. So since this only has a reliable 45-minute runtime, and it's really inconvenient to run off of AC power off the plug at the bedside, you run it for battery. This will be the last intervention you do before taking the patient from the facility, going down the hallway, getting into the ambulance, and then the first thing you do is hook it into AC power. So let's go ahead and review the features that are on this. One of the nice aspects is that it is very, very basic. It's literally numbered 1, 2, 3, 4, 5, and then this should say 6 and 7, but it doesn't, unfortunately. That would be a better mental cue. The nice thing is they are in red, and that's going to be your high pressure and your low pressure dial. The other downside with this particular ventilator is that these knobs, they're turn knobs. They have an electric readout right here, and these knobs are extraordinarily sensitive. You're going to go from like 12 breaths to 14 breaths, and you give it the tiniest little touch, and it shoots right up to 24. And it can go all the way up. I believe the max is out at like 100 breaths a minute. That's inconvenient when you're bumping down the road in an ambulance, or even if you were in a helicopter and you're in an aircraft and receiving turbulence. That's really inconvenient. So it's one feature that I don't like, but I do like the fact that it's built like a dump truck and it's extremely basic. So your basic features, you've got off, AC, SIMV, CPAP, and cal for calibrate. We want to go ahead and just turn it on to AC. So we'll review these knobs real quick. Sorry, I know that it's hard to be fully in the camera and for you guys to be able to see everything. So you can see off, AC, SIMV, CPAP, and calibrate. The other thing is, once you go from off to on, it immediately starts ventilating at whatever these are already set at. And there's no electronic reset. The knobs are the knobs, so it's kind of like the volume in your car. If somebody turns the volume up, turns the car off, turns the car back on, you're going to get blasted with volume. The knob stays where the knob stays. So now we've got our knobs, and you can see the numbers 1, 2, 3, 4, 5, and then we should have 6, 7, but we have high pressure, low pressure. So first knob is our setting. Say we select assist control. We're now going to go to our ventilator rate, and it is reading out right here, and it's showing at about 10 breaths a minute. It'll fluctuate a little bit, 9, 10. If you got your I time, or your I to E ratio, okay, that's going to automatically change based on your ventilatory rate and your tidal volume. But you can change it if for some reason you need a greater exhalation time or a less of an exhalation time. Okay. Now we move to our tidal volume. Right now it's set at 450, roughly. It says 452, 450. And then finally, it's got the bleed of our FiO2. The bottom, 0, is going to be 21%, all the way up to max at 100%. And it's alarming because the 50 psi line is not currently hooked up to an oxygen source, and it can sense that. That's kind of a nice feature, because if you were to run out of oxygen or forget to hook it up to oxygen, it's alarming you, telling you that there's something wrong. So once we solve the issue, the alarm automatically goes off. But if we had the issue and the alarm's going off, we can hit the alarm silence button right here. And it's just going to mute it for a little while. It'll eventually come back on because we don't want alarms to ever be fully muted. So we'll turn that off for right now. The other aspect we have is we have external air, a sigh, and PEEP. You also have a manual breath trigger down here. So if you're reconfirming your tube placement, or you move the patient, anytime we do a patient movement, the tube should always be checked. So here is your, if it's very low breath, low volume, and very slow, then we need an actual breath. So we can breath, and then check the other side, and we can go ahead and take a breath. Just be careful of air stacking. You don't want to end up having barotrauma. Finally, we have our high pressure setting, and that one's right now, it's currently set at 46. We can go ahead and drop that down. And at the moment, we're going to go ahead and drop it down to 35. And then, of course, our low pressure alarm, we never want it set on 0. So right now, it's set on 8, and that's a nice safe setting. So if there was a vent disconnect or some other issue, you would immediately start getting alarmed because you have pressure lower than 8. The last aspect is going to be your PEEP. Your PEEP's right now set at 0, and you just press it to bring it up. And you can press and hold, or you can press it once. We're at 6. Here's one other downside with this vent. If I wanted it to be at 5 and I came up to 6, the only way to get it back to 5 is to round the horn. It goes all the way up to 20. So now suddenly I've got to press and hold and let it go all the way up to 20, and then back to 0, and then bring it right back up to 5. So the patient's going to get probably 1 or 2 breaths at that much higher PEEP. I don't like that feature, but that's what you have to work with. So that's pretty much it, the overview of the ventilator operation for transport vent for this particular model. This is not the primary model we use, but this is the first one that we train on because all the functions are so extraordinarily basic. It is, however, still in our service. It's a backup ventilator, so if the other one's being used or it's out of service for some other reason, you will still be required to understand and be competent on this particular device. So feel free to review this video as often as you need to, and come on down and let's do a hands-on demonstration and make sure everybody feels comfortable. Until then, have a great day, love, protect, and help, and I'll see you later.